Alright, this is our Chapter 9 study guide, the section that you are allowed to use the calculator on. So your calculator's out at this time is okay. The first 4 questions have us matching each graph with its function. So there's a few things that we can do to make this really simple. So let's just take a look at number 1. Y equals negative 2x squared plus 2. One of the key features about number 1 is the first thing we see is that the leading coefficient is a negative. And since it's a negative, we know that that makes a frowny face parabola. So knowing that fact, we know it's either A or we know it is D. So then to get the difference between A and D, we look at their y-intercepts. The y-intercept for A is 2. Well, if we look at the equation for number 1, our standalone number is 2, which means that's our y-intercept. Or if we wanted to prove it, to get a y-intercept, you take the x out and put a 0 in its spot. And if you do that, order of operations, you would get A2. So 1 has to match up with A. Well then, since I only have one other frowny face parabola left, I'm going to go look at the equations for the next frowny face equation, which would be 2. So 2 and D have to match up. So we got the first 2 questions done fairly quickly. Now number 3, we've got a positive in front, which means we've got a smiley face parabola. So again, we're only between options B and C. So if I look at 3, the y-intercept, if I put a 0 in for x, out comes a 0 for y. So B's y-intercept is negative 4, C's y-intercept is 0. So the y-intercept of 0 has to be with C because that's for equation 3. So it goes A, D, C, and finally B for number 4, but we can check it to make sure. Positive smiley face, y-intercept of negative 4, and that's exactly what we have here. So the first 4 were fairly easy because all you're doing is matching them. You didn't actually have to do all the graphing parts. Alright, next, number 5, we have to find the equation of the axis of symmetry and the coordinates of the vertex. So remember, we've got a formula that does this for us, and let me focus in on here. And our formula for the vertex and the axis of symmetry is negative b over 2a. And for negative b over 2a, vertex ends in an x. So remember, that was one way that we said we can remember that the vertex formula gives us always an x value. And this does not want to focus today. Maybe next year I'll have a better camera. Sorry for this. Okay. So vertex ends in x, so it's going to be negative b over 2a. So we look at our equation, and we have a problem. Well, not really a problem, because we know that in order to get your a, b, and c value, it's supposed to be ax squared plus bx plus c. Well, there is no x in this equation, which means the b value is 0. So b is 0. Our a is the number in front of x squared, which means a is equal to negative 4. So let's plug things in and see what happens. So this would be negative 0 over 2 times negative 4, which would be negative 0 over negative 8, which just gives me 0. This number gives us 2 parts of our answer. It gives us the first part, the axis of symmetry. The axis of symmetry is x equals 0. So that would give you half credit. Now to get the other part of the question, the coordinates of the vertex, well, we have the x coordinate. The x is 0. So anytime you have an x and you want a y, you simply take out your x and plug in what you need it to be. We need this to be a 0. So 0 squared would be 0. 0 times negative 4 is still 0. Add 3 to 0 and we get 3. And that is our vertex, 0, 3. So this is your AOS, the axis of symmetry. And then this is your vertex, 0, 3. 6 is going to be a little bit more difficult because we're going to get a fraction here. Because here, our a value is 1 and our b value is 5. So we use our vertex formula, negative b over 2a. So this is going to be negative 5 over 2 times 1, which gives us negative 5 halves. So we can now get the axis of symmetry, because that's what the x in the vertex gives you, the axis of symmetry. So x equals negative 5 halves. That is your AOS, axis of symmetry. This is what would cut your parabola right down the middle, this vertical line. Now we've got to get the y coordinate. So we're going to go plug this in and just do our order of operations. So I know you can use a calculator in this section. However, I'm going to just do it without a calculator because I'm going to keep it in fraction form. So we have y equals negative 5 halves squared plus 5 over 1 times negative 5 halves. Let me make that a little bit better. And then minus 12 over 1. So negative 5 halves squared is going to give us 25 over 4. This is going to give us negative 25 over 2. And this is still 12 over 1. So from here, common denominators, because we have fractions. So common denominator is a common multiple of 4, 2, and 1, which is 4. So that 25 is going to stay the same. To make the 2 to a 4, I multiplied it by 2. So I have to do the same thing to 25. We multiply it by 2, which gives me 50. To make the 1 a 4, I multiply by 4. So I do the same thing to 12. Multiply it by 4, which gives me 48. So at this point, I now have 25. Take away 50, which is negative 25. Then subtract 48 from that, which gives me negative 73 over 4. And I now have my vertex. Negative 5 halves, comma, negative 73 over 4. And that gives us our final answer for our AOS. I'm sorry, for our vertex, because we already got the axis of symmetry earlier. So this is our vertex. All right, moving on to the next question. All right, for number 8, it says for our equation, once it focuses in, all right, it says for the equation y equals negative 4x squared plus 12x minus 15, and wants the range and the domain. Remember, the range is what y values do we hit? What y values? Now, we can't list every single y value because this is a picture. It's impossible. So we have to give a statement. So the way we do this is, let's first look at this. Because our leading coefficient is a negative, that means we know that this has to form a frowny face parabola. So if I'm talking about the y values, remember y values are the up and down values. Well, this thing goes down forever. So these are going to go all the way down to negative infinity. However, it does not go up forever. This parabola stops at the very top of it. Well, remember, this top is a very special point. That's what we call the vertex. So if we can figure out what the vertex is, we can figure out the highest y value it hits. And that's exactly what we're going to do. So we're going to take our equation. We're going to use our vertex formula. So negative b over 2a. Our b value is 12. So it's going to be negative 12 over 2 times a. Our a value is negative 4. So that's going to give me 12 over 8, because a negative over a negative makes a positive. And 12 over 8 makes, if we divide both of these by 4, we get 3 halves. Now that's the x value. I now need the y value. So I need to plug this into the equation. And again, you can use your calculators at this point, but I'm going to do it without a calculator. So we have y equals negative 4 times 3 halves squared plus 12 times 3 halves minus 15. So that's going to be negative 4. 3 halves squared gives you 9 fourths, because 3 times 3 is 9. 2 times 2 is 4, because we're squaring it. Then we've got 12 times 3 halves, and that's going to give me 18. And then we have minus 15. Well, here's the nice thing here. This is why a calculator really isn't that necessary. 4 and 4 cancel, so now you just have negative 9 plus 18 minus 15. Negative 9 plus 18 is 9. 9 minus 15 is negative 6. So your vertex is located at, there we go. Your vertex is located at 3 halves, comma, negative 6. So that negative 6 is the biggest y value it hits. It hits everything underneath it, which means your y values are less than or equal to negative 6. Now, if this parabola would have been facing upwards, a smiley face, then it would have been y is greater than or equal to negative 6. But because this goes down, this is going to hit all the y values under negative 6. Then they ask for the domain. The domain are your x values. Again, it's impossible to list every single x value. So we want to try to figure out where does it stop hitting the x's. Just like we figured out where did it stop hitting y's, which was up here. Well, on this thing gets fat forever. So nothing ever stops it from growing bigger. So this one is all x values. It never stops hitting x's. So that's why our domain is all x values. Okay, so that's for number 8. Moving right along to number 9, it says, and let me get paper out from underneath here so it doesn't look. Number 9 says the combined area of 2 squares is 45 square centimeters. Each side of one square is twice as long as the side. Okay, so we've got squares. I can't keep track of all those squares in my head, so I like to draw them out. So we've got one square, and we have another square, because it says we've got 2 squares. And it says that the total area is 45, so square 1 plus square 2, so square 1 plus square 2 equals 45. And it says each side of one square is twice as long as the side of the other. So let's just make this x. This will be our first square. So all these are sides of x because it's a square, they're all the same. And it says another square is twice as long. So twice as long as x would be 2x. So we're going to make each of these over here 2x. And now they're talking about the area. So area we find out by multiplying the length and the width. So the area of the first one, x times x, which is x squared. The area of the second one would be 2x times 2x, which is 4x squared. So square 1, let's go back to this formula because it says the 2 squares together make 45. So square 1 is x squared. Square 2 is 4x squared, and that equals 45. So from here, now we can solve for x. Let's combine like terms. 1x squared plus 4x squared is 5x squared. So 5x squared equals 45. Now we don't have to worry about factoring because we just have x squareds only, so we can play the game of opposites. So to get rid of that 5, since it's a multiplier, we divide. So now we get x squared equals 9. To undo squaring, we're going to take the square root. Square root of 9 is positive and negative 3, because we're solving for a variable, so you have to do the positive and negative. Then we go and look at our problem. It says what is the length of each side of the larger square? Larger square, larger square, larger square. This is the big one, so it's going to be 2 times 3 or 2 times negative 3. Well, since it's geometry, it can't be 2 times negative 3 because you can't have negative length. So this is just 2 times 3, which gives us 6. So 6 is our final answer. On to our next page. So again, this is in the calculator section, but you can see that the calculator hasn't really been needed at this point, unless you wanted to check your work with the calculator. But all these questions are still fairly simple calculations to do. All right, we have an equation of a parabola. They want the vertex. So 2 ways of doing this. We could do the vertex form, where we do negative b over 2a. That will give you your x. Then you can plug that in here to get your y value, which is fine, but I'm going to go do it the more sophisticated way by completing the square. So to complete the square, I'm going to take this 3, move it off to the side because I need an open spot here. So that's going to be y minus 3 equals x squared plus 4x. Then the rule for completing the square is you take half of your middle term, which in this case is 4, and then you square that. So this is going to be 4 over 2, that's me taking half of it, squaring it. So 4 over 2, let me focus in again. 4 over 2 is 2, 2 squared is 4. So I'm going to put a plus 4 over here. Now that's a brand new number, So I got to put the exact same thing on the other side to balance it out. So here's what we've got. Negative 3 plus 4 is positive 1. Let's try something here. Okay. Then over here, the whole reason we complete the square is because we can factor it. We can factor it using a diamond, what two numbers add to give you 4, multiply to give you 4, or the shortcut for completing the squares after you do it, the factored form is just the square roots of the first and last. So the square root of x squared is x, square root of 4 is 2. So this becomes y plus 1 equals x plus 2 squared. Now I just got to get that 1 to the other side. So y equals x plus 2 squared minus 1. So now I'm in vertex form. So therefore the vertex, remember it's always the opposite of what's with your x. So instead of positive 2, it's a negative 2. And the y value is always what you see. So negative 1. And again, you could have done it the negative b over 2a method, plugged in your x and done order of operations. But I did complete the square since we learned how to do that in this chapter. All right, b, what is the y-intercept? So go to our equation, y-intercept, you make the x's 0. That means they cancel out all together and you're left with just a 3. So the y-intercept is 0, 3. Next it says, what are the x-intercepts? So for our x-intercepts, we know that the y value has to be 0. And this is where this can kind of come in to be easier now if you're in vertex form. So I'm going to take this y, you could plug it in here, you can make your y 0, and then factor, or put 0 in for y here, which I'm going to do. So 0 equals x plus 2 squared minus 1. And since it's already factored, I can just play the game of opposites. So to get rid of that minus 1, I add it. So I have 1 equals x plus 2 squared. My next step would be to get rid of the squared. So I take the square root, take the square root. I'm solving for a variable, so when I take the square root, I've got to do the positive and the negative. So the square root of 1 is positive and negative 1, and that is equal to x plus 2 because I got rid of the squared. So now to get rid of that 2, we subtract 2. So x is equal to negative 2 plus or minus 1. So now you just have to do that. So we do the first one. Negative 2 plus 1 gives me negative 1. Negative 2 minus 1 gives me negative 3. And those are your x-intercepts, which you could have gotten as well by factoring your original. And if you factor the original equation, that would have been x plus 3 times x plus 1 equals 0. So x equals negative 3, x equals negative 1. So both of them give you the same answers. It's just whatever you feel more comfortable with. Now we're going to use all that information to make the graph. So to make the graph of this, I'm just going to put the y-intercept down first. So 0, 3. I'm going to put my x-intercepts down next, which is negative 1 and negative 3. Then our vertex, which was up earlier from negative 2, negative 1. And again, parabolas are symmetrical, so that axis of symmetry goes right down the middle, which means every point has a partner on the other side. So this y-intercept is 2 from the axis of symmetry, so I have to have another point 2 to the left, which means that is at negative 4, 3. And then we connect them, make a curve, not lines, but a curve, and don't forget your arrows, and you have your parabola. All right. Then on to number 11. It says the sum of, okay, so we have another area problem. And again, it's another sum of the areas. So it tells us the sum is 80. So circle 1 plus circle 2 is equal to 80 pi. So they give us the diagram. This time we don't have to figure it out. They want us to figure out the radius of the larger. So this is what we're going to be going for. So let's do what they've told us, the sum of the areas. So let's find the area of this one. And again, your area formula is pi r squared. So for this one, it would be pi times 2r squared. So 2r squared is 2r times 2r, which is 4r squared. And then when we write things in pi form, we usually like to write the whole number in front. So I'm going to say the area is 4 pi r squared. That's for our first one. Second one, even easier. Area equals pi radius, which is r squared. So it's simply just pi r squared. Now it says the sum of the areas, which means I'm going to take big area, small area, and put them in their equation. So circle 1 was the big one, so 4 pi r squared. Circle 2 was the small one, pi r squared. Remember, there's really a 1 in front if you want to put it there, equals 80 pi. So let's combine like terms, because these are both r squareds. So 4 pi and a 1 pi make a 5 pi. Now our goal is we're solving for the radius. So we want to get the radius by itself. So this 5 pi is a multiplier, so I'm going to divide by 5 pi. So I'm left with just r squared. I'm going to come over here and divide by 5 pi as well. So the pi's will cancel out. So I just have 80 divided by 5, which is 16. So to get rid of a squared, square root, and we get r is equal to plus minus 4. But since it's a geometry problem, we're only going to use the positive. So r is 4. So that means, and here's where you got to be careful. Actually, this time, the final question wants to know what is the radius of the larger circle. So here's the larger one, 2r. So if r is 4, then we do 2r, so that's 2 times 4, which is giving us a radius of 8. So 8 is our radius. Okay, it says for the picture below, write the equation of the parabola in vertex form or standard form. Well, let's be smart about it. Vertex is always going to be the quicker way to write things. So all we got to do, let's find the vertex. So on here, -1 is the x, down to -4. So our vertex is -1, -4. So vertex form, we know, is y equals a, and that's the important part, a here, because we don't know what a is, x minus h squared plus k. So since we identified the vertex from the picture as being -1, -4, we just need to plug this in. So y equals a, which we still don't know, x, this has a minus h, which means use the opposite of your x. So instead of a -1, it's going to be a +1 squared, plus k, that means use the exact number. So our k value, or y value of the vertex is -4, so we put in a -4. Now the only problem is we don't know what a is. So in order to figure a out, all we have to do is if we could plug in an x and a y, then the a could be solved for. But where am I going to get an x and a y? Anywhere from your picture. Any point from this picture. So the first one that sticks out to me is this point. 0, -3. So 0, -3 is on our picture, which means it has to work in our equation. So this says -3 is the y. So I'm going to take that y out, put in a -3. Still don't know a. X is 0. So take the x out, put in a 0. And now we can solve for a. So -3 equals, this becomes 0 plus 1, which is 1. Now we square it, which is just 1 squared is 1, minus 4. Well, 1 times a is just an a. So let's make that look a little bit normal, more normal. So -3 equals a minus 4. To get a by itself, we add 4, and we get a is equal to 1. So therefore, we can say y is equal. We can put a 1 in here if we want to, or it's not needed, it's just understood it's there. So x plus 1 squared minus 4. And that's in vertex form. For those of you that went all the way to standard form, let me write that down. Let's see, you would have x squared plus 2x plus 1 minus 4, so y equals x squared plus 2x minus 3. That would have been standard form, but you only need one or the other. You do not need both. All right, and then on to our last question in the calculator section. It says Moore hits a baseball into the air. The equation, let's get this focused. This is the equation that models the height, and they want to know how long is the ball in the air. So let's just take a rough sketch. This is a parabola, frowning face, so it goes like this. So this is the ball. This is the ball traveling in this kind of an arc. And we want to know how long is the ball in the air. So it starts here, and it's going to end somewhere. Well, the ball is no longer in the air when the height is equal to 0, because it's on the ground. So all we got to do is take this height equation and make the height equal to 0, and we can solve for t. So 0 equals negative 16 t squared plus 60t plus 3. So we've got two options that we can do, three options. We could try to factor it, we could complete the square, or we could use the quadratic formula. And since we haven't done the quadratic formula yet in this study guide for the calculator section, I'm going to do the quadratic formula. So in the quadratic formula will be given to you on the day of your test, so you don't have to worry about memorizing it. That was just for the state exam. So I need the A, the B, and the C. So A is negative 16, B is 60, and C is 3. So now let's just plug it in. So negative B, so negative 60 plus minus square root B squared, so 60 squared minus 4 times A, which is negative 16, times C, which is 3, all over 2A, 2 times negative 16. So I'm going to come and do this part first. This is called your discriminant, because this is going to let us know if we even have an answer to begin with. Because if we get a negative under here, there is no answer. So let's see what happens. So order of operations, 60 squared, that's going to give me 3,600. Now when I do the multiplication, I like to multiply with this negative to get rid of it. So I'm going to do negative 4 times negative 16, which gives me a positive 64, times that by 3, which gives me a positive 192. So since it's a positive answer, I put a plus 192. Remember, this is under the square root, so we are going to have an answer. So 3,600 plus 192 gives us 3,792. So now we let the calculator do really the rest of the work, because here's what we've got. We've got negative 60 plus the square root of 3,792 over, and let me do this multiplication, 2 times negative 16 is negative 32. Your other answer is negative 60 minus the square root. That's that plus minus. So now we got to subtract the square root of 3,792 divided by negative 32. And this is where you let the calculator do the work. So let me calculate that off to the side. This first one gives you approximately negative 0.05. I'm going to round to the nearest thousandth. And then the second one gives me approximately 3.8. Well, because this is a real-world problem, the negative doesn't make sense. You can't be in the air for a negative amount of time. So we have to go with the 3.8 answer. And on the test, it will tell you what to round to. I know I forgot to put it on the directions here, so I just rounded to the nearest tenth on this one. On the second one, I rounded to the nearest tenth. And that's it for the calculator part.